Ain't it the truth? All right, let's get into this practice test. So first, adding. Not going to lie here, if you get the adding wrong, you probably shouldn't be in this class because adding is going to be the easiest question you have on this test. So I'm adding my two functions. You have to know the function of f is going to be x squared minus x minus 12. My function of g is going to be x minus 4. I don't need parentheses because adding you don't need that. Remember that this x right here, that's just telling you that's your input. That's what you can put stuff into. The x is only there to say that's your variable that you're dealing with. So now if I combine my like terms, I have x squared. These two cancel each other out. Wham, bam, thank you, ma'am. And then I still have these two to add together, and I get negative 16, and that's my answer. Next one, my function of g. So my function of g is x minus 4. Subtract. Make sure to put this in parentheses. You have to put this in parentheses, or else you will get the wrong answer. You have to subtract this whole equation. The whole equation, not just the first term. This is like a negative 1 out in front, so you multiply that negative 1 in. Of x minus 4, this becomes a negative x squared. This becomes a positive x because a negative 1 times negative 1 is positive, and negative 1 times negative 12 will give you a positive 12. Again, my like terms here are these two and these two. So I have a negative x squared. X plus x will give me 2x, and negative 4 plus 12 will give me a positive 8. And that's my final answer. Multiplying. So my two equations that I'm multiplying is going to be my x squared minus x minus 12. And I also have my x minus 4. Again, there's two ways you can do this. You can either do this the box method, or else you can do it the foiling. So I'm going to do a foiling first. So I have my x squared times my x, that gives me x cubed. X squared times negative 4, that gives me negative 4x squared. Negative x, remember this is a negative x times x, it gives me a negative x squared. Negative x times negative 4, positive 4x. Negative 12 times x, negative 12x. Negative 12 times negative 4, positive 48. That would be if you did it the swoosh swoosh rainbow way. If you did it the box method. Either way, your 6 terms should be the same. In the box method, these should be like terms. When you do it the other way, you should have 2 terms that are like terms. So in this case, my final answer would be x cubed minus 5x squared, because I'm combining my like terms, minus 8x plus 48. Again, my like terms, negative x squared minus 4x, that's where the negative 5 comes from. Positive 4 minus 12, that's where the negative 8 comes from. It's the same thing as if in the box method. Dividing, my favorite, your favorite too, I know it. So my function of g is on top. Function of g is x minus 4 over your function of f, x squared minus x minus 12. First step, write it out. Second step, 2 factor. So I have x minus 4 over x minus 4 times x plus 3. Two numbers that multiply to get negative 12 and add together to get negative 1. A lot of times when you're doing this, since this right here is on top, you would want to try to find a factor that maybe would include this, because probably will be used. You want to find your domain restrictions next. So x minus 4 cannot equal 0, and x plus 3 cannot equal 0. Because if they did, then you would not be able to solve the problem, because you cannot divide by 0. That's a big no, no. You can only cancel it out if you have multiplying. So this whole thing is multiplying, so I can cancel this and this out because it's the exact same. This is on bottom, it should stay on bottom. So to represent on bottom, I'm going to keep a 1 up top. So this is my final answer right here. It looks like a boot. And my next 3 questions. So big box, little box. My first thing I'm going to do is zoom in. Oh. That is not multiplying. It is not multiplying. It's saying the composition. It's saying one inside of the other. So you can rewrite it like this if you so wish to. My 2 equations that I'm dealing with is my function of h. So I'm going to write that out. My function of h is this. My function of f is this. Whichever one's on the inside, big box. Whichever one's on the outside, little box. Because you're replacing. When something on the inside goes inside, it gets replaced. It's substituted in. So when I write out this equation, it says 4 times box plus 5. Again, I'm looking right here. It says 4 times box. You're replacing the box plus 5. Distribute that 4. So this is 4x squared minus 8 plus 5. And I can combine these two like terms. So I have 4x squared minus 3 is my answer. Next one, I'm actually evaluating. Question number 5, it started with an x. Question number 6, it starts with a number. When you start with an x, your answer should have an x. If you start with a number, your answer should have a number. So I'm looking at inside first. It's always focusing on the inside first. So inside is this right here. So if I look at this, what this is actually saying is my function of h, which my function of h is 4x plus 5, evaluated x is equal to negative 3. That's what this is saying. This is saying my function of h evaluates when x is equal to negative 3. So it would be 4 times negative 3 plus 5. So you get that answer. And that answer would be negative 7. So again, when I'm looking at this problem, this is equal to negative 7. This is equal to negative 7. So I can replace that. So I have my function of f at negative 7 because you're replacing it. Now you're dealing with the outside equation. Again, what this is saying, my function of f. So my function of f is x squared minus 2. And it's saying x is equal to negative 7. That's what this portion is saying to you right now. Without saying anything, that's what it's saying. Make sure to have this in parentheses, because if you don't, you're not going to get the right answer. So if I evaluate the function of f at x is equal to negative 7, I would get 47 out. That's my answer. And the last one, still a composition problem. I'm going to write out my two equations. So I have 4x plus 5, that's my function of h, and my function of g, x squared minus 5x plus 4. Whatever is on the inside, big box, because that's replacing, that's substituting in. Outside, little box. So this says 4 times box. Remember, you are replacing, you're substituting your box. 4 times box, you're switching in your box, plus 5, and you distribute. So 4 times all these beautiful numbers, and you can combine these two like terms, 4x squared minus 20x plus 19. See you on the flip side. Flipped. Okay, your first 3 questions are solving. So I'm solving for x. I'm trying to get x by itself. Remember, you're working backwards from PEMDAS. Backwards from PEMDAS means you want to get rid of any adding, subtracting. So I'm going to add 5 here. I'm going to add 5 over here. So this is the square root of 5x minus 4. This would be equal to 4. Square root, the opposite of the square root is squaring something. Remember, this would be like 2 over 1. Since this right here is odd, you only have one answer. These two cancel each other out, leaving you with just 5x subtract 4 is equal to 16. You add over your 4, you get 20. You divide by 5, you get x is equal to 4. Next one. I already have my fraction exponent by itself, which is awesome. So I have to raise this guy to some sort of power. Remember, a power to a power you multiply. If I want to get rid of this power, I want to multiply by the reciprocal. So whatever I do to one side, I do to the other side. So that I'm going to do 5/3 power to the people on both sides. So these two, power to a power, these cancel out, just x plus 2. And then I do a 27 to the 5/3. Again, looking at the bottom, this is odd, so there's only going to be one answer. 27 to the 5/3 power is 243. You subtract 2 from both sides, you get x is equal to 241. Bing, bada, boom. Last one. Again, work backwards from PEMDAS first. So I'm looking at this problem. I'm first going to get rid of this 2. Subtract 2 from both sides. I have 3, x minus 4, raised to the 4/3 power is equal to 48. Then you get rid of this 3 times. So the opposite of multiplying is dividing. So I have to divide by 3 on both sides. X minus 4, 4/3 power, is equal to 16. And then you get rid of that power. Power to a power, you multiply. So I want to have my power be 3/4. Again, the reciprocal. Whatever you do to one side, you have to do to the other. So these two cancel each other out because it's multiplying. So I just have x minus 4 here. This 16 raised to the 3/4. 3/4. It's even. Even should have positive negative. This is positive negative 8. I would always write this step out because you would hate to do all of this work and then get it wrong because you did simple math wrong. Make a positive 8, make a negative 8. You add the 4 over on both of them. X is equal to 12, x is equal to negative 4. Those are your 2 answers. Again, 2 answers because when you were solving right here, you had an even exponent. And graphing. Okay. You don't want to hear me? Wasting time. Transformation. The 5 in front would be a stretch. So it's going to stretch 5, and this is where you're going to find your second points that will be included. Inside the equation moves left and right. Inside is opposite, so it's going to move left 3. Outside the equation moves up and down. Outside the equation is as shown, so if it says subtract, that means it's going moving down 4. So the first thing I'm going to plot is left 3, down 4. 1, 2, 3, 4. It's not as easy with the not real pen. Write down that point. I would write down that point. That point is very important. That point is going to help us with the domain and range. That point on my graph. Now, you can plug in any other numbers towards the right of that point in your equation. I'm going to pick negative 2. I'm going to pick 1, and I'm going to pick 6. Because when I plug this into my equation, I'm only going to write it out once. You plug it in right here. If I plug that into my calculator, negative 2 plus 3 times 5 subtract 4, you would get 1 out. If you plug 1 into your equation, you would get 6 out. If you plug 6 into your equation, you get 11 out. So now I have 3 points that I can plot. So I have negative 2, positive 1. Right here, about 1 and 6. 1, 2, 3, 4, 5, 6. And 6, 11. It's off the charts, man. It should be a curve. It should be a curve, and it should be pointing to the right. So that's what that looks like. Why was it important to write out this point on your graph? Because that's the point that's your domain in your range. Your x and your y. When I look at this, x is getting larger, so x is greater than because it is moving to the right. When you move to the right, it's positive. When I look at this, y is getting larger, so it's greater than because from this point it's moving up. So that's moving up, y is getting larger. So that would be done with that one. Next one, my transformation. It's going to flip or reflect over the x-axis, and it's going to move up 2. So when I do this, when I go up 2. That's the point. That point you should write down 0, 2. That's an important point to help you later. So when I do this, again, you can pick any numbers towards the right of that. I'm going to pick 1, I'm going to pick 4, and I'm going to pick 9. Why? Because those are all perfect squares. And in my equation, I have to take the square root of a perfect square to make a nice number. So if I plug in 1, I would get 1 out. If I plug in 4, I would get 0 out. If I plug in 9, I would get negative 1 out. When I plot this, I have 1, 1. I have 4, 0. And I have 9, negative 1. And I draw it to the right, and this one's going down. So again, that point, this point is very important. Now, this is my x, this is my y. When I look at this point, it's moving to the right. My x is moving to the right. That means x is getting larger. Moving to the right is larger. When I look at this from this point, it's going down. Y is going down because of this flip you had here. Since it's moving down, y is getting smaller, so it's less than or equal to. And there you have it. You're going to ace the test tomorrow because you are amazing and you watched this video and yeah, amazing stuff. Have a great, grand, wonderful part of your day. Just, yeah, cheers. Keep on living. Keep on keeping on. Frickman, stop talking. Oh my gosh, you're weird. Okay, I'm so excited to grade your test because you're going to get an A. Bam.